Hi, welcome to Wise Guys. This video is on the right triangle and it's a couple of practice questions. So what you can do is pause the video, walk through this question, and then turn the video back on and I'll walk through the question. Okay, so here we have a right angle triangle. We're told that the angle alpha is 23 degrees, so that's what we have right here, is 23 degrees, and side A is 72. All right, and sometimes it helps to just do this. Remind yourself of your trig functions. The sine of the angle, opposite over hypotenuse, tan of the angle, adjacent over, oh man, keep doing that wrong, opposite over adjacent, so that's supposed to be an O, and the cos of the angle is adjacent over hypotenuse. All right, so we have angle, we have adjacent, B is the opposite side. All right, C is the hypotenuse. So let's say we decide to solve B first. Actually, let's solve the angle first. Let's solve for theta. So theta equals 90 degrees minus 23 degrees, which equals 67, I think. Yep. So 67 degrees, which is alpha. Okay. All right, now let's go back to solving for B. So we would be using tan because we're looking for the opposite and we have the adjacent, so opposite over adjacent. So the tan of our 23 degrees equals the opposite side, which is B, over the adjacent side, which is 72. We want B by itself, so we multiply here by 72, and we multiply this by 72. These are gone, so B equals 72 times the tan of 23. And we end up with 30.5. So B equals 30.5, and we're rounding to 2 sig figs, so that becomes a 31. Okay. And again, we can see that it's reasonable that it's small. This angle is small, so this side has to be small with respect to the 72. So now let's solve for C, and again, we're just going to use trig functions because that's what we're working on here. We know this side, which is our adjacent. We want our hypotenuse. So adjacent and hypotenuse, that's cos. So the cos of 23 degrees equals 72, which is our adjacent, over our hypotenuse, which is C. So we want C by itself. So and right now it's in the denominator, right? So we need to get it up into the numerator. So we multiply here by C. We multiply on this side by C. We have to multiply on this side by C. The only reason we're multiplying it here again is to get this thing up into the numerator. These two cancel because they're 1. So we have C cos 23 degrees equals 72. But again, we want C by itself, and it's multiplied by the cos of 23 degrees. So we divide by the cos of 23 degrees, and we do the same here. These two are gone, and we're left with C equals 72 divided by the cos of 23 degrees. So 72 divided by cos 23 equals 78.2. So C equals 78.2, 2 sig figs, that would be 78. And that is our C. Now we also know that the hypotenuse has to be the largest side. Here's our 72. We're saying C is 78. That's a reasonable answer. So we can say, you know what? We're probably right. So here's the second question. Again, you can pause the video, try the question. Notice that we have 3 sig figs here. Walk through it, and then turn the video back on and I'll walk through it. Or I should say restart the video. Okay, we're back at it. All right, so alpha is 48.7 degrees and side B is 12.5. So we can see that B is adjacent to alpha. This side here is the opposite side, and this side here, the long side, is always the hypotenuse. And sometimes it just, when you're working through the question, it just helps to just name them. What have I got here? So let's say we decide to solve for A. This is opposite. We have adjacent, so then we would use tan. Oh yeah, and let's just solve for theta first. So theta equals 90 degrees minus 48.7 degrees. .3 degrees. And that's theta. All right, now we'll solve for A. So the tan of 48.7 degrees equals the opposite side, which is A, divided by the adjacent side, which is 12.5. Okay, so we want A by itself, so we multiply here by 12.5. We multiply here by 12.5. These two are gone, and we're left with A equals 12.5 times the tan of 48.7. And we've got 14.2. So A equals 14.2. Now, when I'm looking at my triangle, my first reaction to that is, wow, that seems kind of small. Okay. However, notice that we have an angle here of 48.7, which is pretty close to 45 degrees. When we're dealing with a 45 degrees, the two sides are always equal. With the way the triangle is drawn, it doesn't really look like that, but the truth is, it is close to 45, so they should be close together. Now let's solve for the hypotenuse, and again we'll solve for the hypotenuse by using this side. So that is adjacent over hypotenuse. Adjacent over hypotenuse is the cos. So the cos of 48.7 equals the adjacent side, which is 12.5, over the hypotenuse, which is C. We want C by itself, so what we do then is multiply here by C and multiply here by C. These two cancel, and so we have C times the cos of 48.7, which equals 12.5. Now again, we want C by itself, so we divide here by the cos of 48.7 degrees, and sorry, that's wrong, divided by the cos of 48.7. C equals 12.5 divided by cos 48.7 equals 18.9. Okay, so there's C. So we have 14.2 here, 12.5 here. We're saying the hypotenuse is 18.9. That's a reasonable answer. It's got to be bigger than those two, so it makes sense. All right? So, and that was brought to you by Wise Guys. You have a good day.